Today, I will be presenting my model of the solar system. As a quick disclaimer before we start, I wanted to note that some aspects of the model are not 100% accurate. For example, the ratio and proportions of the planets and moons are not properly represented. The measurements in degrees are in Celsius, and the distance are in kilometer. Lastly, the measurement marked as AU means astronomical unit. 1 astronomical unit is the distance from Earth to the Sun. The Oort cloud. The Oort cloud is a giant spherical shell surrounding our solar system. It is found beyond the Kuiper belt and beyond influence of the sun's magnetic field, lying in interstellar space. The inner edge of the cloud is thought to be between 2,000 and 5,000 AU from the sun, while the outer edge might be 10,000 to 100,000 AU from the sun. The cloud is composed of icy, comet-like objects. They can be found as small as dust particles and can be as large as mountains or even larger. The mass of the cloud is estimated to be 10 to 100 times that of Earth. Within the cloud, there are trillions of objects, with larger ones counting as dwarf planets. The icy bodies are primarily made of water, methane, and other ices, although some cloud objects could be pristine chunks of the sun's early life, formed at the beginning of the solar system, and then pushed by gravity to the outer reaches. Unlike most objects that orbit the sun, the cloud is likely a full sphere surrounding the solar system, like a thick-walled bubble of ice chunks in space. The comets inside the cloud orbit the sun on a sphere with no preferred orientation. They come into the inner solar system from random directions in the sky. Although information can be estimated from the Oort cloud, the existence has never officially been confirmed. The Kuiper belt. The Kuiper belt is located in the outer reaches of our solar system, mainly beyond the orbit of Neptune. The inner region of the belt is at 30 AU from the sun, while the end of the main region is about 50 AUs. The scattered disk continues beyond 1,000 AU away from the sun. The belt is a donut-shaped region of icy bodies that circle the outer solar system, extending beyond the orbit of Neptune, mainly containing ice particles of methane, ammonia, and water. The hundreds of thousands or perhaps millions of icy bodies in the belt are called Kuiper belt objects, or KBOs, or trans-Neptunian objects, or TNOs. Pluto, who was once considered a planet but has now been demoted, resides in the belt along with other KBOs. Although the belt takes up a significant amount of space, the total mass is estimated to be around 6% that of Earth. The belt is one of the largest structures in the solar system. It orbits the sun farther away from Neptune, and most KBOs have a stable, nearly circular orbits that are not disturbed by the gravity of Neptune. The existence of the belt was confirmed in 1992 and was named after a Dutch astronomer, Gerald Kuiper, who proposed its existence in 1951. The asteroid belt. The main belt lies between Mars and Jupiter and spans a region about 225 million kilometers across. The inner area of the belt is at 2 AU from the sun, while the outer area is upwards of 4 AU from the sun. Similar to the Kuiper belt, the asteroid belt is a disc-shaped region consisting of pieces of rock left over from the dawn of the solar system. Created during the early life, the majority of dust and rocks were being pulled together by the gravity of the sun, which not all turned into planets, and the leftover created the asteroid belt region. Within the belt lies millions of asteroids, most relatively small, about the size of a boulder and up to a few thousand feet in diameter, but some are significantly larger. Most asteroids in the belt are made of rock and stone, but a small portion contains iron and nickel metals, and a distant portion is made of ice. The objects in the belt are divided into weight subgroups, named after the main asteroid in each group. The total mass of the belt is less than that of our moon, and it orbits between Mars and Jupiter. Neptune. Neptune is the 8th and furthest planet from the sun. It is found at 30 AU from the sun, and at this distance, it takes sunlight about 4 hours to travel to the planet. Neptune is considered an ice giant, and is the 4th largest planet in the solar system, measuring almost 50,000 kilometers in diameter, which is about 4 times wider than Earth. Discovered in 1846 by Johann Galle, Neptune was named after the Roman god of the sea. Fun fact, Neptune was the first planet to be discovered by mathematical calculations. Neptune's composition. The planet's blue color comes from methane in its atmosphere, which allows some color to reflect back into space while trapping others. Neptune's core is composed of rocks, while its outer layer, called the mantle, is mainly water, methane, and ammonia. More than 80% of Neptune's mass is made up of materials such as water, methane, and ammonia, which surrounds its rocky core. Scientists think there might be an ocean of extremely hot water under the planet's cold clouds, but the pressure is keeping it locked inside. Without any solid surface, Neptune's atmosphere, made up of hydrogen, methane, and other gases, extend to great depth, which gradually merge into the outer layers of the planet. There are at least 5 rings surrounding the planet, and at least 4 ring arcs that we know of so far. Neptune's moons and orbit. Neptune is the home of 14 known moons. The largest one, Triton, was discovered in 1847 by William Lassell, only 17 days after the discovery of the planet. The most recent moon was only discovered 11 years ago. As astronomy and spaceflight develops, it is likely that more moons will be discovered in the future. Each moon on Neptune is named after mythical sea creatures. Neptune rotates on itself slightly faster than Earth, with a day on the planet lasting about 16 hours. This means that it takes 16 hours for the planet to make a full rotation on itself. A year on Neptune, which is a complete orbit around the Sun, is done in about 165 Earth years. Neptune's axis of rotation is tilted at 28 degrees of its orbit around the Sun, which means it has a similar tilt to Earth. This means that Neptune experiences seasons similar to Earth, except for the fact that each season lasts over 40 years. Uranus. Uranus is the 7th planet from the Sun and lies at a distance of 19.8 AU. From this distance, it takes sunlight about 2 hours and 40 minutes to reach the planet. Uranus is the biggest ice planet in the solar system, measuring over 50,000 kilometers in diameter and ranking 3rd largest in the solar system. Discovered by a German-born musician and astronomer, William Herschel, the planet was named after the Greek god of sky, which was suggested by Johann Bode. Similarly to Neptune, Uranus gets its blue-green color from the methane gas in its atmosphere. Composition of Uranus. Uranus took shape about 4.5 billion years ago when gravity pulled swirling gas and dust, creating this ice planet. The planet has 11 rings separated into 2 categories: the inner system, which consists of 9 narrow dark gray rings, and the outer system, which consists of 1 reddish ring and the second a blue ring. More than 80% of Uranus's mass is made up of a dense fluid of icy materials, mainly water, methane, and ammonia, with a core of about 50,000 degrees Celsius made of rock. Uranus's moons and orbit. Uranus is the home of 27 known moons, each named after characters from the works of William Shakespeare and Alexander Pope. The composition of the inner moons are reported to be half water and half rock, while the composition of the outer moons remain unknown. A day on Uranus takes about 17 hours. This is to rotate once around its axis, compared to a complete orbit around the Sun, taking 84 Earth years, which is 1 Uranian year. Uranus is also one of 2 planets that rotate in the opposite direction than every other planet, Venus being the other one. Uranus is also the only planet with an orbit tilted at 97 degrees, which could have been caused by a collision with an Earth-sized object a long time ago. This causes Uranus to have the most extreme seasons, consisting of 21 straight years of direct sunshine and another 21 years of dark, frigid winters. Saturn. Saturn is the 6th planet from the Sun, with an average distance of 9.5 AU. From this distance, it takes sunlight 80 minutes to travel to the planet. Measuring over 120,000 kilometers in diameter and 109,000 kilometers pole to pole, Saturn is the 2nd largest planet in the solar system. Named after the Roman god of agriculture, Saturn is the furthest planet visible from Earth visible to the naked eye. Saturn's composition. Saturn's rings are a staple part of the planet. Although the other Jovian planets also have rings, Saturn's outstanding features are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet. The planet and its atmosphere is made up of gas, mainly hydrogen and helium, similar to Jupiter and the Sun, while its core is mainly composed of liquid and solid metallic hydrogen. Without a true surface, the planet is mostly swirling gases and liquids. Saturn's moons and orbit. Saturn is the home for a variety of moons, with a total of 146 moons in its orbit as of June 8, 2023, with others continually awaiting confirmation of their discovery. Considering the planet's high spin, Saturn has the 2nd shortest day in the solar system, taking 10.5 hours. This causes the planet to bulge at its equator and flatten at its pole. It makes a complete orbit around the Sun in about 29.4 Earth years. With an axis tilted by about 27 degrees with respect to its orbit around the Sun, Saturn experiences seasons similar to on Earth. Next up is Jupiter. Jupiter is the fifth planet from the Sun and orbits at an average distance of 5.2 AU, but truly ranges between 4.2 and 6.2. From this distance, it takes sunlight 43 minutes to travel to the planet. Jupiter is approximately 143,000 kilometers in diameter, making it the largest planet in the solar system. The planet is so large that according to NASA, it is more than twice as massive as all the other planets combined and could hold more than 1,300 Earths. Discovered in 1610 by Galileo and named after the king of ancient Roman gods, the planet helped revolutionize the way we saw the universe. Jupiter's composition. Similar to the other Jovian planets, Jupiter has rings, which were noticed when NASA's Voyager 1 spacecraft discovered them around the planet's equator in 1976. Jupiter's rings are made of continuous streams of dust particles emitted by some of the planet's moons. Being a giant gas planet, Jupiter does not have a solid surface. The planet's composition could be divided into three sections. First, its atmosphere contains gas, helium, and molecular hydrogen. Second, the mantle is made of metallic hydrogen. And last, its core, whose structure is still unclear, but thought to be made of solid metal or of molten rock. Moons in orbit. Jupiter is also known for its spectacular 79 known moons, named mainly after paramours and descendants of the Roman gods. The four largest moons of Jupiter, called Ganymedes, Io, Europa, and Callisto, were all discovered by Galileo and are often referred to as the Galilean moons. Ganymedes is the largest moon in our solar system. It is known for having its own magnetic field and having at least one ocean between layers of ice. Jupiter has the shortest day in the solar system. One day on Jupiter is about 10 hours and makes a complete orbit around the Sun in about 12 Earth years. Its equator is tilted around the Sun by just 3 degrees, meaning the planet spins nearly upright and does not have as significant seasons as other planets do. Mars. Mars is the furthest terrestrial planet and is fourth from the Sun. At an average distance of 1.5 AU away from the Sun, it takes sunlight 13 minutes to reach the planet. With a diameter measuring about 6,750 kilometers, Mars is about half the size of Earth and is the second smallest planet in the solar system. The planet was named by the Romans for their god of war because of its reddish color, which reminded them of blood. Although water exists on Mars, the atmosphere is too thin for it to last in liquid state on the surface. Instead, the water is found below the surface as water ice. The average temperature on the planet is right around the minus 60 degrees, although it can vary from minus 125 to plus 20, depending on the seasons and the location of the planet. Mars's composition. To the naked eye, Mars appears reddish at its surface. This is caused by the rusty atmospheric dust. The atmosphere is composed of over 90% carbon dioxide, around 3% nitrogen, and the rest is oxygen and argon. Mars has a pressure at the surface of 6.35 mbar, which is over 100 times less than Earth's. Mars has a 4,000 kilometer wide core made of iron, nickel, and sulfur. The center of the planet is covered by a rocky mantle, which on average is about 1,500 kilometers thick. And above is a crust made of iron, magnesium, aluminum, calcium, and potassium. This crust is between 10 to 50 kilometers deep. Moons in orbit. Mars has two small moons, Phobos and Deimos. These potato-shaped objects are thought to be captured asteroids and got their names from horses that pulled the chariot of the Greek god of war. The innermost and larger moon, Phobos, is heavily scarred with deep craters on its surface. Its trajectory is slowly moving towards Mars and is expected to crash into the planet in about 50 million years. Deimos is about half the size of Phobos and orbits about 2.5 times farther away from the planet. The surface of the oddly shaped moon is covered in loose dirt, which often fills the craters on its surface, making it appear smoother. A day on Mars is very similar to one day on Earth. It takes the planet 24.6 hours to make a complete rotation on itself and orbits the Sun in 687 days, which is 1 year on Mars. The planet's axis is tilted 25 degrees with respect to its orbit to the Sun, similar to Earth's tilt, meaning Mars has distinct seasons slightly longer than on Earth, but they vary in time since Mars orbits the Sun on an elliptical, egg-shaped pattern. Earth. Earth is the third planet from the Sun and is at a distance of exactly 1 AU away. It takes about 8 minutes for sunlight to reach our planet. With a diameter of about 12,750 kilometers, which is the biggest terrestrial planet and the fifth largest in our solar system. Unlike the other planets in our solar system, which are named after Greek and Roman gods and goddesses, the name Earth is a German word which simply means the ground. The name is at least 1,000 years old. While hunt for life beyond Earth continues, for the time being, our home planet remains the only place in the universe where we've identified living organism. Earth's composition. The current best estimate for the mass of Earth is 5.972 times 10 at the 24th exponent kilograms. Earth is composed of 4 main layers, which include the inner core, the outer core, the mantle, and the crust. The inner core is a solid sphere made of iron and nickel metals, and it's almost 2,500 kilometers in diameter. The temperature in the inner core can be as high as 5,400 degrees. The outer core is about 4,600 kilometers and is made of iron and nickel fluids. The mantle is the thickest layer of our planet, and it is a hot, vigorous mixture of molten rock and is about 5,800 kilometers. The last layer, Earth's crust, is on average 30 kilometers deep on land, although at the bottom of the ocean, the crust can be as thin as 5 kilometers. Earth's global oceans represent nearly 70% of the planet's surface and has an average depth of about 4 kilometers. Our atmosphere consists of 78% nitrogen, 21% oxygen, and 1% other gases such as argon, carbon dioxide, and neon. Additionally, our atmosphere affects the planet's long-term climate and short-term local weather. It also protects us from meteors, burning them before they can strike the surface, which are seen in the sky as meteors. Its moons and orbits. Earth is the only planet to have a single moon. Our moon is the brightest and most familiar object in the sky. The moon stabilizes the planet's wobble, which has kept the climate more stable over thousands of years. The moon has a diameter that measures about 30,000 kilometers, making it the fifth largest moon in our solar system, and on average keeps a distance of 380,000 kilometers between itself and Earth. Earth completes a rotation on itself, one day, every 23.9 hours, and completes a trip around the sun, 1 year, in 365.25 days. This extra quarter of a day, which represents a challenge to our calendar system, is the reason why every 4 years we add 1 day, which is called a leap year. Earth's axis of rotation is tilted 23.4 degrees with respect to its orbit around the sun. This tilt is the reason for our yearly cycle of seasons. Venus. Venus is the second planet from the Sun and orbits from an average distance of 0.72 AU. From this distance, sunlight reaches the planet in about 6 minutes. The planet measures about 12,100 kilometers across, ranking it the third smallest planet and just slightly smaller than Earth. Because of its thick atmosphere, heat is trapped in the planet, making it the hottest in our solar system, with surface temperatures hot enough to melt lead. Venus, being the third brightest object after the sun and moon, was named after the ancient Roman goddess of love and beauty, and it is the only planet named after a female god. Venus's composition. The planet is made of an iron core that is roughly 6,000 kilometers wide, followed by a molten rocky mantle that is roughly 3,000 kilometers thick. Venus's crust is mostly basalt and is estimated to be 10 to 20 kilometers thick. Similar to the composition of Earth, although its atmosphere is made up mainly of carbon dioxide and nitrogen, with traces of carbon dioxide and other substances. Due to Venus's reflective clouds, the planet is highly visible from Earth, but up close, it is reported that the color of Venus is a rusty color, with tinges of red, brown, and yellow. Cornell University suggests that this color comes from the number of volcanic rocks dotting the surface, as Venus is a highly active world. Its moons and orbit. Venus has no known moons, which makes it quite unique in our solar system, as the only other planet without moons is Mercury. A day on Venus would be 243 Earth days long, which is even longer than a Venus year, which only takes about 225 Earth days. Venus is only tilted to 3 degrees, which is too little to produce noticeable seasons. Similarly to our moon, Venus has phases, a full, half, and quarter, etc. The complete cycle, however, takes 584 days, while our moon takes just a month. Mercury. Mercury is the closest planet to the Sun. On average, it is about 58 million kilometers away, or 0.4 AU. From this distance, it takes sunlight 3.2 minutes to travel from the Sun to Mercury. Mercury is the smallest terrestrial planet, but is the second densest planet in the solar system, right after Earth. Only slightly larger than Earth's moon, Mercury's diameter measures about 5,000 kilometers, a little over a third of the width of Earth. The surface temperatures are both extremely hot and cold. Since the planet is close to the Sun, it can reach temperatures as high as 450 degrees, but since the planet does not have much of an atmosphere, at night, temperatures can drop to minus 180 degrees. Mercury gets its name from the swiftest of the ancient Roman gods. Mercury's composition. Composed mainly of iron and nickel, Mercury is the second densest planet, and its core represents about 85% of the planet's diameter. Its outer shell, the mantle and the crust, is comparable to Earth's in composure, although it's only about 400 kilometers thick. The atmosphere of Mercury is a surface-bound exosphere, which is essentially a vacuum containing oxygen, sodium, hydrogen, helium, and potassium. About 4 billion years ago, an asteroid roughly 100 kilometers wide struck Mercury, creating a vast impact crater roughly 1,550 kilometers wide, known as the Caloris Basin. The planet is also pockmarked with other craters since the non-significant atmosphere does not stop impact. Its moons and orbit. Just like Venus, the planet does not have any moons or rings. Mercury orbits the Sun faster than all the other planets in the solar system, traveling at speeds of nearly 180,000 kilometers an hour. At this speed, Mercury orbits the Sun in only 88 Earth days, which is 1 year on Mercury. Although a year on this planet is so short, a day on Mercury lasts 58 Earth days, which is why it is called a 3-to-2 spin-orbit resonance with the Sun. With an axis of rotation tilted just 2 degrees with respect to its orbit around the Sun, Mercury hardly experiences seasons as other planets do. And lastly, we have the Sun. The Sun is the heart of our solar system, where it is by far the largest object. It holds 99.8% of the solar system's mass and is roughly 109 times the diameter of Earth. About 1 million Earths could fit inside the Sun. The Sun measures a surprisingly 1.4 million kilometers in diameter. The surface of the Sun is about 5,500 degrees, while temperatures in the core reach higher than 15 million degrees. The Sun orbits some 25,000 light years from the galactic core, completing a revolution once every 250 million years or so. The star is about 150 million kilometers away from Earth and orbits the center of the Milky Way, bringing with it the planets, asteroids, comets, and other objects in our solar system. The Sun's composition. The Sun is driven by nuclear reaction. It has enough nuclear fuel to stay as it is now for another 5 billion years. After this, it will swell and become a red giant. Eventually, it will shed its outer layer, and the remaining core will collapse to become a white dwarf, and eventually fade. This is the process of any dying star. Just like most other stars, the Sun is mostly made of hydrogen, followed by helium. The rest of the matter consists of oxygen, carbon, neon, nitrogen, magnesium, iron, and silicon. For every 1 million atom of hydrogen in the Sun, there are just under 100,000 atoms of all the other materials combined. The Sun is separated into 3 sections. The Sun's first layer consists of the core, which extends from its center to about a quarter of the way to its surface, but only makes up for about 2% of the volume of the star. The core of the Sun can measure up to 15 million degrees Celsius. The second layer, the radiative zone, extends from the core to 70% of the way to the Sun's surface, making up for 32% of the volume and 48% of its mass. The last layer is called the convective zone. This represents 66% of the Sun's volume, but only a little more than 2% of its mass. The majority of this zone is taken by rolling convection cells of gas. 2 types of these cells exist. First, the granulation cells, 1,000 kilometers wide, and the supergranulation cells, about 30,000 kilometers wide. Similarly, the atmosphere of the sun is separated into 4 sections. First, the photosphere is the lowest layer of the atmosphere. This section is what emits the light we see from Earth. This section is about 500 kilometers thick, and temperatures range from 6,000 degrees to over 4,000 degrees. The second layer is the chromosphere. This section is significantly hotter than the first, with temperatures hovering around 20,000 degrees and is about 10,000 kilometers high. Next up is the transition region, which is a few thousand kilometers thick, which is headed by the last section, the corona. This section is a super hot layer made of structures such as loop and streams of ionized gas. The corona generally ranges from 500,000 to 6 million degrees, and occasionally, when the solar flare occurs, it can reach tens of millions of degrees.